So what we're going to look at right now is we're going to be looking at what are called sets. And so a set is a group of elements. Okay. Sometimes it's numbers, oftentimes it's numbers, but sometimes it's not, right? Okay. So it's a group of elements without any repetition. So we're going to first define that, and that's first what it is to be a set, okay? So like, for example, we might have the set, we'll call it S, and the set S is the numbers 1, 3, 7, and 9. Okay, 1, 3, 7, and 9. On the other hand, we might have a different set, call it D, and D might be the elements A, C, F, and G. Or we might have another one, a different one called E, and E we might call a star, clover, horseshoe. These are I call them my lucky charm sets. Okay? So those are what we call sets. So sets are any set of objects, doesn't really matter what it is. Okay? We can, and basically that's fundamentally what it is. There it is. That's a set. Okay? What we do is we use these little curly brackets. They just tell us what things are in the set. We denote each element of the set by a comma. All right? But they can basically be anything that we want them to be. All right? Now, once we know what a set is, the next thing that we want to get about a set is something called its cardinality. And the cardinality of a set is the number of elements that are in the set. So like the one here, that's called an element. Or member, right? Okay, so we might also call it a member of the set. So cardinality can also be thought of as the number of members in the set. Okay, so that's what cardinality is. And how we denote it is we write it as n, right? N, and then we use parentheses, and then we put it whatever the set is. So n of S is going to equal 4 because there are 1, 2, 3, 4 elements in S. So n of S equals 4. On the other hand, if we look at n of D, we're going to ask for the cardinality of D, and D also has 4 elements or 4 members. 1, 2, 3, 4. Right? A, C, F, and G, so there are 4 in that set. And then the cardinality of E is going to equal 3. That's the number of elements that are in the set E. Okay? So that gives us our basic definitions. Right? What is a set? A set is a grouping of elements or members. They could be anything that we want them to be. Okay? We define them oftentimes with these big letters. They're going to be in these brackets. Okay? And each member is going to be denoted with a comma. Secondly, we got the idea of cardinality. And the cardinality is the number of elements in the set. And we write that as n of, and then we define what the set is. So what we'll do is we'll go in, we'll see S, I'll look at S, and I'll see, oh, okay, I've got 1, 2, 3, 4 elements in S, so that's the cardinality of S. The next thing I want to look at is something called a union of sets. So now what we're going to do is we're going to talk about what happens when we take 2 or more sets and we do something with them. Like in this case, what we're going to do is something called unioning. All right, so unioning of sets is where we bring together all of the different elements in the sets and we remove anything that's a repetition. So a union of 2 sets, 2 or more sets, is the collection of all of the elements that are in one or the other. It's a collection of all of the elements in one set or the other. So let's take a look at this because oftentimes it's going to be a lot easier to kind of understand what a union is after looking at the set. So the first thing I want to do is I want to notice that this thing here, that U means union. All right, so when I see the U, it's going to mean a union. And so let's define 2 sets. I'm going to have A, and A is going to equal 1, 2, 3, 4. And B is going to equal 3, 4, 5, 6. And the question that I want is I want to get what is A union B? Okay? Now, again, a union is going to be all of the elements that are in one set or the other. And we're going to remove the repetitions because that's what we do when we have sets. So I'm going to take this, and this is going to be then 1, because 1 is an A, 2 is an A, 3 is an A, 4 is also in A. And I'm going to notice that I'm now going to go over to B because I need to include all the elements that are also in B, but I don't want the repetition, so I'm not going to rewrite 3 and 4. I don't need to rewrite them. Now I'm just going to write 5 and 6. So 1, 2, 3, 4, 5, 6. That's A union B. Now, one of the things that we want to get about constructing these sets, right, is in addition to, right, I now have A union B, I want to ask what is the number or the cardinality of A union B. And in this case, I look at the final set, 1, 2, 3, 4, 5, 6. That has 1, 2, 3, 4, 5, 6 elements. So the cardinality of A union B is 6, right? You construct the set and then count. Let's look at another example. Let's say, for example, that I have C equals star, moon, and horseshoe. And I have that D is equal to moon, horseshoe, balloon. So C union D now, okay, follow along with me, is going to equal then, it's going to be star, because that's in C, moon, because that's also in C, horseshoe, because that's in C, and then we're going to go over to D, because we finished with all of C. We're going to go over to D. We're going to notice that moon and horseshoe are already in C union D, so we're just going to bring over the last element, that's balloon. So that ends up being balloon. Okay? And then the number of C union D, or the cardinality of C union D, is going to equal 4, because there are 4 elements inside of that set. So that's the union. The union is the collection of all elements that are in one or the other or both of the sets. That's a union. So next up inside of our basics are intersections. So the intersection, where we use the word and, is the collection of elements that are in both groups. So let's say, for example, that we have A, okay, which is equal to, and it'll be 1, 3, 5, and 7. And then we have B, which is equal to, okay, 2, 3, 6, and 8. The intersection of the two is going to be the element or elements that are in both groups. Well, if we look here, only one of those elements, 3, is actually in both groups. So A intersect B is equal to 3. And the number of elements in A intersect B is going to also equal 3. Is equal to 1. There's only one element there. Pardon me. Is equal to 1. Let's take a different look. Let's say, for example, C equals shoes, socks, and shirts. And B equals pants and hats. C intersect B in this case is going to be what we call the empty set, where we use a 0 with the line slash through it, the empty set. The reason why it's going to be the empty set is because there is nothing that is in both. Notice that shoes, socks, and shirts, none of those are in pants and hats. And so consequently we have the empty set. Alright, so when we talk about an intersection is It's the collection of elements that are in both groups. Okay? And by the way, the cardinality of an empty set of C intersect B is going to equal 0. Okay? So this thing here, the empty set, that is a set with nothing in it. And the cardinality of the empty set is 0. It should also be stated that the number 0 is actually an element, right? Because we could have the number 0, so that's why we put the slash through the 0. So what we're going to look at now is we're going to talk about this thing called the universe of a set or a set of elements, and then the complement of a set. So the universe is actually like the collection that we're pulling sets from. All right, so it's not necessarily, we may not define it, we define it as a set itself, but it's like this thing, and we're going to say, okay, so here's all the stuff that we could be pulling from, right? And then we're going to pull our set A from it, or we'll pull our set B from it, or whatever it is, okay? Whatever it is that we're looking at. So let's imagine that we have our universe, and we'll define our universe, and our universe is going to be this set. It'll be the set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it'll be the numbers 1 through 10. And so we'll start out with that. That's going to be all the numbers that we're going to pick our set from. And so in that, we have this set. The set's going to be 1A, 1, 3, 5, 7, and 9. So that's going to be the set A. Okay? Now, what we're going to do next is we're going to define something called the complement of a set. So the complement of the set A, called a complement, is the set of all elements that are in the universe, but that are not in A. So if we define a complement, okay, then that's going to equal, well, we see that 1 is in A, so we don't want A in a complement, all right? But 2's in the universe and not in A. 4 is in the universe, but it's also not in A, because notice that 3 is in A, so we don't want 3. We only want the stuff in the universe that's not in A. Okay? Then we got 6, we got 8, and we have 10. So those are all the elements that are in the universe, but that are also not in A. Let's take a look at another example. Let's say, for example, we'll define our universe as socks, shoes, pants, shirts, and hats. And let's say, for example, A, our set A, is the set of socks and pants. A complement will be all the stuff that's not in A, but that is in our universe. So consequently, we will have shoes, shirts, and hats in A complement. And that's how we define a complement. So we've got this universe. The universe is the set of all elements, right, that are going to make up the world that we're looking in or that we're observing. And then our complement is going to be all the stuff that's in the universe, but not in the set that we're finding the complement of. And how we denote it with a little c. That c means the complement. Now that we've defined all of our different kinds of sets, and those are the basic ones that we're going to be using here, now what we want to do is we want to talk about multiple sets and what we call an order of operations. So normally we're going to work from left to right, just as if we would read in English, okay? But sometimes what we're going to get is we're going to get multiple sets and we're going to have to perform operations on them. And one of the key things that we need mathematically is we need to know what things should I do first, okay? So the order of operations for sets is to do parentheses first, then do complements, and then we'll move from left to right doing intersections and unions, okay? So like, let's say, for example, I look at something and I'm going to say that A equals 1, 2, 3. B equals 3, 5, and 7. Okay? C equals 2, 4, 6, and 7. And we'll define our universe, because if we have to use complements, we're going to need a universe, and we're going to define our universe as all of the integers from 1 through 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we're going to have that be defined as our universe. Let's take, for example, something where we look at, we have A complement union B. So we have A complement union B. According to our order of operations, we would do parentheses first, but there are no parentheses here. So we're not going to do any parentheses. So next up, we're going to go do complements. So that's our next step. And so we'll do the complement of A. So the complement of A, if you remember, is everything that's in the universe that's not an A. So that's going to be 4, 5, 6, 7, 8, 9, and 10. And we're going to union that with, now, the set B, which is 3, 5, and 7. So if we go in, remember that the union, right, gives us all the elements that are in one or the other without repetition. Notice that 5 and 7 are already in both sets. So this is just going to be 3, that's the one from B, and 4, 5, 6, 7, 8, 9, and 10. And that, in fact, is A complement union B. Let's try it again. Let's try it this time. We'll do something like this. A intersect B union C. In this case, there are no parentheses. There are no complements, so we're just going to move from left to right. So we'll start out with A union B. So A union B, we'll do that part first, and that's going to be then 1, 2, 3, 5, and 7. And then A intersect B. It is not A union B, it's A intersect B. So A intersect B. And so if we look, the only one that they have in common is the number 3. So we are going to, that's going to be now 3. 3 is A intersect B. We'll union that with C now. And C is 2, 4, 6, and 7. Remembering that the union is the set of all elements that are in one or the other, this is going to give me then 2, 3, 4, 6, and 7. So I did the intersection first, and then when I was done with the intersection, I did the union. If you did it the other way around, you'd get a very different set of numbers. Okay, so we're going to go from left to right. Next up, what about this? Let's take now A intersect B union C, but we're going to put B union C in parentheses. So that means that we're going to do B union C first, and then we'll intersect it with A. So B union C is, we already know, well, okay, is going to be 2, 3, 5, 6, and 7. Right? We're going to take everything that's in one or the other. And then we're going to intersect that now. We're going to take that and we're going to find the intersection with A. So we'll intersect it now with 1, 2, and 3. And so now we see that 2 and 3, they are the ones that are in common with both. So consequently, we get 2 and 3. And so what should be clear is how different that is than what we did before. Let's take a look at another example. Let's say, for example, now I have A complement, and I want to union that with B intersect C complement. So what I want to notice is that B intersect C complement's in parentheses, but inside of the parentheses now I have C complement. So that means that I've got to do C complement first, then I'm going to do B intersect C complement, and then I'm going to take A complement and I'll union the two of them together. So I'll take, let's just keep it at A complement for right now, and we'll union that with B. So that's going to be, B is 3, 5, 7, and the complement, we're going to intersect that with the complement of C, which is going to be 1, 3, 5, 8, 9, and 10. So now I'll take that complement. So I now get a complement intersected with, and this is now going to be 3, because they both have 3 in common. They both have 5 in common. It could be 3 and 5. So it's just going to be a complement intersected with 3 and 5. And a complement is going to then be 4, 5, 6, 7, 8, 9, and 10. And what we'll do is we'll union that with 3 and 5. Because that's the last piece. So that's going to end up equaling 3, 4, 5, 6, 7, 8, 9, and 10. So what I did here was I first said, okay, I'll take C complement because it was inside of the parentheses. Then I took the intersection because it was still inside of the parentheses. Once I had that, I took A complement, right? Because I do after parentheses, I'm going to do complements. And then I'll go from left to right. Let's take a look at another example. So here's another example. We've got our universe now of A, B, C, D, E, F, G, and H. Okay? And then we have these sets that are within that universe. A, which will equal B, D, F. B, which will be A, B, C, D. And C, which is B, E, F, G. So now let's take a look at a set of multiple operations. So we'll have A, and we'll union that with B, and then we'll intersect that with C complement. So remembering our order of operations, we're going to need C complement first. So one of the ways that I might do this is I'll find C complement first. So there's C complement. And so it's going to be A, C, D, H. So it's everything that is in the universe but not in C. Next up, I'm going to now do A union B because I don't have any parentheses. I've done all my complements. And so I need to go do A union B. Okay. And A union B is then going to be A, B, C, D, and F. So that's all the values that are in A or B or both. A, B, C, D, and F. And now I'm going to intersect that with C complement. So I've got the 2, right? Okay, I've done my order of operations. So like I did this first, did this second. Now I'm going to do this third. I'm going to take A union B intersect C complement. So that means that I'm going to intersect these 2. So the intersection there is then going to be A, C, D. And that is my final answer. That is the intersection of those 2. Let's look at one more example. Let's say, for example, that what I do is I take A union B, and then I go in and I complement it. A union B complement. So parentheses are what we do first. So 1, I need to find A union B. And so A union B is going to equal A, B, C, D, and F. Now I'm going to need to take the complement of that because I did what was in the parentheses first. Now I need to take the complement of the entire set. So what I get is I get A union B complement is now going to be everything that's not in this set A union B. So it is going to be E, G, and H. And that is the complement of A union B. So again, we're working with multiple sets and multiple set operations. We want to remember that we're going to do our parentheses first, then we'll do complements, and then we'll do order of operations goes from left to right. And this completes the entirety of our beginning set operations.